So let's now proceed with conditional probability. No? So here we have the probability that event B occurring given that event A has already occurred is known as conditional probability. So, yung probability na mangyayari yung isang event given na yung isang event ay nangyari na, ang tawag doon ay conditional probability. So, meron ka ditong event. Ano ang tsansa na mangyayari ito kung nangyari na yung nakalipas? No? So, ganun siya. Ganun yung conditional probability. The probability that that event B occurring given that event A has already occurred is known as conditional probability. So, here's the notation. Probability of occurrence of event B given that event A has occurred. So, ito yung notation natin. B, tapos merong separator. So, this is a probability of occurrence of event B given that event A has occurred. No? And this is the formula for a conditional probability. So, probability B given A, o kaya, sabihin mo na lang, probability B given A. Automatic probability of occurrence of event B given that event A has occurred. Ang shortcut ng pagbasa, probability of B given A. Okay? So, equals to probability A intersection B, no? Or A and B, yan din natin. Probability of the occurrence of both events, A and B, no? So, over probability of A. So, ito yung intersection symbol, occurrence of the two events, no? Both occurrence of the two events, A and B, no? So, over probability of A such that probability of A is greater than 0. No? Probability of A is greater than 0. So, that is true. Kasi, kapag nag-0 yung denominator, magiging undefined siya, right? Makakaano tayo ng invalid answer pag 0 yan. No? So, para maiwasan yan. So meron siyang limitation. Hindi dapat maging 0 yan. Okay? So, we can now proceed. So, we now proceed with independent events. So, pag sinabi natin independent events, so two events A and B are independent if the occurrence of A does not affect the probability of occurrence of B and vice versa. So, kapag yung dalawang events, no, masasabi natin yung independent. Pag yung dalawang events, masasabi natin independent. Pag yung, halimbawa, nag-occur yung isa. Ngayon, ano yung chance na mag-occur yung isa given na nag-occur na yon? Or should I say ganito na lang? So, let's say, meron akong event A. No? Nangyari yung event A, ang probability ay ito. Okay? Let's say, halimbawa, probability of A, 0.8, halimbawa. Hindi pa nangyayari yung B. Okay? But, probability of B is 0.6. So, ito, probability of A, given na hindi nangyari yung B. 0.8. Ito, probability of B, given na hindi nangyari yung A. 0.6. Okay? So, yan ang interpretation of probability of A given na nangyari yung B. Pag yan, naging 0.8 pa rin, ibig sabihin yan, A is an independent event. No? A is an independent event. Dahil despite na nangyari yung event B, hindi naapektuhan yung probability of occurrence ng event A. 0.8 pa rin na maintain. No? 0.8 pa rin na maintain. Okay? So, ganun din dito. Okay? Probability of B given A. Sabihin yan, the probability of the occurrence of event B given that A has already occurred, no? Pag yan, equal pa rin dun sa event, equal pa rin dun sa probability ng event B na kung saan ang A ay hindi nag-occur. Pagka ganun ang sitwasyon, pag equal pa rin yan, B is said to be an independent event also. Okay? B is also an independent event. Okay? So, masasabi natin na yung dalawang events ay independent ngayon pag yung occurrence ng A ay hindi naapektuhan ng probability of occurrence ng B. Or, vice versa. Yung occurrence of B does not affect the probability of occurrence of A. Okay? So, ganun yung independent events, no? Yung pag-occur ng A ay hindi maapektuhan yung probability ng occurrence ng B. Ganun din, yung occurrence ng B hindi maapektuhan yung probability of occurrence ng A. Okay? So, pagka ganun yung sitwasyon, the two events are said to be independent, no? Okay, so we proceed. So, in this case, ito yung sinasabi ko, probability of B given A equals probability of B. So, probability of B given that A has occurred equals to probability of B given that A has not occurred, or simply ganyan na lang. Okay? Dito naman, probability of A given that B has occurred equal to probability of A given that B has not occurred. So, kapag ka naging equal yung dalawa na yan, okay, masasabi natin that A and B are independent events. Kasi, dapat masatisfy pareho yan. No? So, we can proceed. Example, the event of obtaining a head in tossing a coin and the event of obtaining an odd number in tossing a die. Diba? The occurrence of the event of obtaining a head does not affect the probability of the event of obtaining an odd number and vice versa. So, in short, no? So, if I toss a coin, let's say toss a coin, tossing a coin, in tossing a coin, meron akong event H na lilitaw yung head. Ano ang probability na lilitaw yung head? 1/2. Diba? 1/2. So, naturo ko naman yung introduction sa probability kaya alam niyo na yan, right? And then, and the event of obtaining an odd number in tossing a die. No? Event of obtaining an odd number in tossing a die. So, tossing a die naman ang ating pag-uusapan. Tossing a die. Okay? So, probability na odd number, tossing a die, the event of obtaining an odd number in tossing a die. Ano yung probability of obtaining an odd number in tossing a die? So, yun ang lahat ng mga numbers dun sa die. 6. So, yun yung bilang ng sa sample space. Yun ang lahat ng odd numbers dun sa die. 3. 1, 3, 5. Diba? 3. So, 3/6 is 1/2. Okay? 3/6 is 1/2. Ngayon, given na nangyari to, hindi na ba 1/2 yung makukuha ko dito pag nag-toss ako ng die? Ganun pa rin, di ba? O given naman na naunang nangyari to, yung tossing a die, hindi na ba 1/2 yung magiging sagot ko kapag nag-toss ako ng coin? 1/2 pa rin. So, sabihin niya, they are said to be independent events. No? Tossing a coin and tossing a die. Dahil kahit nangyari yung isa, hindi naman maapektuhan yung tsansa na mangyayari yung dapat mangyari dun sa tossing a die or tossing a coin. No? So, yung probability na odd number, kahit na nangyari yung tossing a coin, 1/2 pa rin. Diba? Yung probability na lilitaw ay odd number given na hindi nangyari yung tossing of a coin, 1/2. So, kapag nangyari, 1/2 pa rin. Diba? So, name-maintain. So, dahil name-maintain, independent. No? So, we can proceed. No? So, dependent event, no? An event B is said to be a dependent event if the occurrence of event A does affect the probability of occurrence of event B and vice versa. So, ito siya. The probability of the occurrence of event B given that A has already occurred is not equal to probability of the occurrence of event B given that A has not occurred. So, ibig sabihin niyan, given na nag-occur yung A, hindi siya equal yung probability ng B na given na A has not occurred, no? Pag hindi naging equal sa probability of B given that A has occurred, masasabi natin na B is a dependent event, no? B is a dependent event. Dahil nung nangyari yung A, hindi na siya equal dun sa event, dun sa probability na kung saan hindi pa nangyari yung A. No? So, ganun yung independent event. No? So, an event B is said to be dependent event if the occurrence of event A, yung event A nag-occur, does affect the probability of occurrence of event B. So, naapektuhan. No? So, probability B given A has occurred. Pag hindi naging equal sa probability of B given A has not occurred. No? Pag hindi naging equal yan, sabihin niya, therefore, B is a dependent event. No? There. No? Probability of B given A has occurred. If it is not equal to probability of B, no? If probability of B given A has occurred is not equal to the probability of B given A has not occurred, no? Therefore, B is a dependent event, no? So, B is a dependent event. So, sabihin niyan, not equal, B is said to be a dependent event. And vice versa. So, let's say, probability of A given that B has occurred, pag hindi naging equal sa probability of A given that B has not occurred, therefore, event A is said to be a dependent event. Pag ito na-satisfy, not equal, A is said to be a dependent event. Okay? So, nagde-depend siya. No? So, meron akong example dito. So, let's say, halimbawa, in a deck of 52 cards, wherein a red card, wherein a card drawn is not replaced. Okay? If B is the event of obtaining a black card, and R is the event of obtaining a red card, suppose B occurs in the first draw, the occurrence of B does affect the probability of occurrence of R in the second draw because of fewer cards left in the deck, unlike if R occurs in the first draw with complete number of cards. Thus, probability of R given B is not equal to probability of R. So in other words, ganito lang yan. So we have a deck of 52 cards, no? So 52 cards. And wherein a card is drawn is not replaced. Okay? So bumunot ka ng card. Ating card na binunot dun sa 52, it is not replaced, no? Now, we have event B. This is the event of obtaining a black card, no? Event of obtaining a black card. And we have also R, which is the event of obtaining a red card. Now, suppose B occurs in the first draw, no? So, suppose B occurs in the first draw. So, if that's the case, the occurrence of B does affect the probability of occurrence of R in the second draw. No? So, first draw. No? First draw obtained, card obtained is black. No? So, card obtained is black. No? And then in the second draw, card obtained is red. So, we have the event B and event R now. No? We have now the event B and event R. No? Now, in this case, the probability of R, no, the probability of occurrence of R, given that B occurs, no, given that event B has occurred, no, sabihin niyan, in the first draw, black yung nakuha, in the second draw, red naman. Katulad ba siya ng probability na red card, given na hindi nangyari yung black sa unang draw? Let's say, sa unang draw, red card, hindi black. No? Let's say sa unang draw, red card. So, kung sa unang draw ay red card, ano yung probability natin? So, kung 52 yan, meron niyang 52 cards, right? In a deck. So, in that case, may 26 red cards. And over 52 yung total number of cards. No? So, 26 over 52. Kasi yung bilang ng mga red cards, 26 over 52 dahil yung total number of cards. And that is 1/2. Ganon din sa black. No? Let's say, sa first draw, nakuha mo, no, ay black card, 26 over 52. 1/2. Ngayon, bubunot ulit ako ng card na kung saan yung binunot kong card, no, dun sa second draw ay let's say nakuha ko ay red. No? Ano yung probability na nakuha ko ay red? Ano yung probability na yon given na nangyari yung first draw? No? Na black card yung nakuha ko. So, katulad pa rin ba siya nung nauna? Na red card na 1/2 yung chance? Tignan natin. Okay. Probability R given B. So, given na nangyari yung unang event, black card yung nakuha. Okay. sa first draw, ano yung probability na red card ngayon sa second draw? Okay? So, in that case, nabawasan na ng isang card dun sa 52. So, 51 cards left na lang. So, over 51 na lang yan. Kasi, sa first draw nangyari, hindi binalik yung card eh. So, 51 na lang yung total number of cards. How about in the numerator? Ano nalagay natin? Sa first draw, ano yung nakuha? Black, right? So, therefore, sa second draw, no, so let's say red na nakuha natin. So, anong probability na red yung nakuha natin? Given na nangyari yung unang event. So, in that case, ilan ang red card sa deck na 52 kung yung sa unang draw ay black yung nakuha? Edi 26, right? We have 26 red cards, no, in the deck. No? Kasi yung unang draw, black yung nakuha, edi may 26 cards pa rin na red, di ba? So 26 over 51. Okay. Equal ba ito dito? Or should I say equal ba ito dito? Equal ba sila? Okay. Probability that event R occurs given that event B has occurred. Is it equal to the probability that event R occurs given that event B has not occurred? No? So dito, pag R lang siya, event B has not occurred. Pag meron siyang ganitong symbol, given that B has occurred, no? Conditional probability to, no? So, are they equal? Ano yung nakuha natin dito? Probability of R, of the occurrence of R, given that B has occurred. So, 26 over 51. So, 26 over 51, is that equal to probability of R, given na hindi nangyari yung event B? Anong event B natin? Obtaining a black card in the first draw. So, in this case, probability na red card, sabihin automatic, dun sa first draw yung tinutukoy nito. No? Dun sa first draw. So, we have 26 over 52, 1/2. So, they're not equal, right? They're not equal. And that is not equal. No? 26 over 51 is not equal to 1/2. So, if that's the case, event R is a dependent event. No? Event R, which is the event of obtaining a red card, is a dependent event. Kasi hindi sila equal dahil ang 26 over 51 ay hindi equal sa 1/2. Okay? So that's it. So kaya sabi dito, this affect the probability of occurrence of R in the second draw because of fewer cards left, because the card was not replaced. No? The card drawn in the first draw was not replaced. No? So in here, unlike if R occurs in the first draw with complete number of cards. Okay? So, kasi yung R, event R na yan, no? Kompleto yung 52 cards sa first draw, no? So, yung red card, no? Yung probability na red yung card ay 1/2. Pero nung nangyari yung unang bunutan, tapos bumunot ulit na hindi binalik yung naunang binunot, so ngayon, magkakaroon na ng pagbabago sa probability na red yung mabubunot. Hindi na siya 26 over 52, 26 over 51 na lang. So therefore, event R is a dependent event because Hindi nag-equal yung dalawa, right? Probability of the occurrence of R given that B has occurred is not equal to the probability of R, no? Given that B has not occurred, no? Automatic, pag ganyan lang, probability of R lang, ibig sabihin yan, given that B has not occurred, no? So, conditional probability applied for dependent events. So here's the problem. The probability that a regularly scheduled flight departs on time is 0.83. So probability that the scheduled flight departs on time is 0.83. No? And the probability that it arrives on time is 0.82. And the probability that it arrives and the probability that it departs and arrives on time. No? It departs and arrives on time. 0.78. No? Find the probability that a plane arrives on time given that it departed on time. So, ano daw yung chance na yung plane arrives on time given that it departs on time? Ayan. So, yun na yung mga given, no? Okay, ito yung nahanap na yan. So, probability that the plane arrives on time given that it departed on time. So, ano yung probability na event A occurs given that event B has already occurred? So, ito yung formula natin. Okay. A, probability of A given D is equal to probability of D and A. No, probability of D intersection A over probability of D. No? Diba? We have the formula for conditional probability. Probability of A and B over probability of A. Okay? So, apply lang natin. So, yung A dito, yun yung B. Yung D dito, yun yung A. Kaya, yung D na to ay yung A. Tapos yung A na yun yung B. Over probability of A. Kung ano nandoon sa pangalawa, yun din yung nandito. Okay? So, we have now 0.78 over 0.83. Okay? And we get 0.94. So, that's the probability that a plane arrives on time given that it departed on time. Alright, so we can proceed. Letter B. Departed on time given that it has arrived on time. So, ano naman yung probability that it departed on time given that it has arrived on time? So, ito yung naman yung ating solution. So D given A. So, kung A yan, A din ito. So, ano tayong A has already occurred. So, sabihin niya, A has occurred. So, A and D. No? A and D. Okay? Kasi, ito yung ating unang consideration. Nag-arrive siya on time. Okay? So, A and D. So, pareho lang yon, D and A and D, 178 pa rin yan. No? So, we can now divide. So, we get 0.95. No? 0.82 kasi yun. Alright? So, we can proceed. Okay, number 2. So a random sample of 200 adults are classified below by sex and their level of education attained. So some are elementary graduates, some are secondary graduates, no? Some are college graduates. No? So in this case, if a person is picked at random from this group, find the probability that the person is a male given that the person has a secondary education. Letter B, the person does not have a college degree given that the person is a female. No? So in this case, solution to the problem. No? Setting solution. So letter A, the person is a male. Okay? Given that the person has a secondary education. So, ano yung probability na male siya given na meron siyang secondary education? So, ito yung solution, conditional probability yan. Probability that the person has a secondary education at the same time the person is a male. Kaya siya intersection and okay, over probability that the person has a secondary education. No? So by classical probability formula, yung probability that a person has a secondary education at the same time it is the person is a male. So we divide the total number of outcomes for the intersection of the two events, no? SEC and N, the intersection of the two events. Then we divide it by the total number of outcomes in the sample space, no? Then we divide it by the number of persons, no, with secondary education. Then we divide by the number of outcomes in the sample space. Okay, so we have number of persons, no, with secondary education and at the same time male. So ito yung intersection, secondary education at the same time male, 28. Kaya 28 yun. Okay, yun yung interpretation yan. Secondary, intersection, and number. Yung bilang. Number, secretary, intersection, and. Okay. Okay. So yun yun, 28. Over 200. Kasi ang total ay 200. No? Ang total ay 200. Check na natin. 38 plus 28 plus 22 plus 45 plus 50 plus 17. 200 ba? So, ito ay 50. 38, 50, 88. 45, 95. 17, 112, 112, and 88. 200. No? So, and then we proceed. No? So, meron tayo number of secretary. Number of with secondary education. We have 28 plus 50. So, pag sinabing number of persons with secondary education, consider mo, male and female yon. No? So, 28 and 50. 28 and 50. Kaya, pag add mo sila, 78 ang total with secondary education. O divide mo ng 200. So, ang lowest term ng sagot ay 14 over 39. No? 14 over 39. So, ganyan yung application ng ating topic, conditional probability. O letter B, the person does not have a college degree given that the person is a female. No? The person does not have a college degree given that the person is a female. Ayan. So in here, no college degree. given that the person is a female. Excuse me. So, kunin natin intersection. Okay? Applying conditional probability formula. No? Then we divide by probability of F. Okay, female. At the same time, no college degree. No? So, female na walang college degree. So, female, at the same time, no college degree. Ito yun, 45 and 50. Kasi, no college degree, under yun ng elementary and secondary. No? So, lahat ng female na walang college degree. So, that is 95 over 200. Kasi yun yung number of, total number of adults na 200. No? And then, probability na female siya. So, pag sinabing probability of female siya, add mo lahat yan. Okay? 45, 50, 17, divide mo sa number of outcomes in the sample space. And we get 95 over 112. Yung kanyang simplest form. Okay? So that's it. I hope you get it. Okay, so here's problem number 3. So this is a problem. It states that in USA Today, the results of a survey involving the use of sleepwear while traveling were listed as follows. So we have a male wearing underwear 0.220, female wearing underwear 0.024, and the total is 0.244. No? So adding the two, 0.220, 0.024, 0.244. Okay? So this is a survey, no? A survey done dated September 5, 1996, no? Regarding the use of sleepwear while traveling. So then we have also here nightgown, nothing, pajamas, t-shirt, and other. So this is already the probability, no? Okay, so these are the probabilities. 0.220, 0.002, 0.160, 0.102, 0.046, 0.084, and so forth and so on. No? So this means that, for instance, the probability uh, that a male is wearing t-shirt is 0.046. So that's the probability, 0.046. No? So the probability that a female wears pajamas while sleeping, no, is 0.073. Okay? So those are the probabilities. No? So in this case, what is the probability that a traveler is a female who sleeps in the nude? No? So we have here the problem. The traveler is a female sleeping in the nude. So what's the probability that the traveler is female? So in that case, here's the solution. So the probability that the traveler is female who sleeps in the nude, so meaning F for female, okay, wearing nothing while sleeping. So the probability is 0.018. So as you notice here, no, this is already indicated in the problem. So we have female, nothing, okay, that is 0.018. Okay, so that is the our answer. So this is the probability that the traveler is female who sleep in the nude. So the intersection of two events, no, so for female and nothing, okay, so we have 0.018. Alright, so we continue. Letter B. What is the probability that the traveler is male? So what's the probability that the traveler is male? Okay, so the probability that the traveler is male, regardless of what he wears while sleeping, no? So is what? We consider what? Hmm? So all of this, no? 0.220, 0.002, 0.160, 0.102, 0.046, 0.084, no? So male wearing underwear, male wearing nightgown, etc. No? So we will add all of these probabilities, no? And that is the probability now that the traveler is male, no? So it includes, no, all these probabilities because it has something to do with male, no? Okay. So in other words, here's the solution. So the probability that the traveler is male is simply we add the probabilities. So we have 0.220 plus 0.02 plus 0.160 plus 0.102 plus 0.046 plus 0.084, and we get 0.614. So that is the probability that a traveler is male, no? Okay? So ito yung survey na natuklasan nila sa US, no? Okay? So let's now continue. So survey na nagawa nila sa US, no? At ito yung kinalabasan, no? So we have letter C, assuming the traveler is male, what is the probability that he sleeps in pajamas, no? Okay? So assuming that the traveler is male, what is the probability that he sleeps in pajamas? Okay, so how is the solution to this? So in other words, what's the probability that he sleeps in pajamas? The person sleep in pajamas, no? Given that the traveler is male. So yan ang hinahanap natin sa letter C. Given that the traveler is male, given na male siya, what is the probability that he sleeps in pajamas? Okay, so how do we solve the problem? So what is our formula again? Probability B given A, no? Condition, we have conditional probability. So let us recall, no? Probability A intersection B over probability of A. Excuse me. So we have here, so B represents pajamas, A represents meal. No? So we have now our solution. Okay, pajamas and meal. No? Over probability that the traveler wears pajamas, or should I say that the traveler is male. No? So this will now be the solution, right? So B for pajamas, A for male. So this is now a pajamas intersection male, no? Meaning, no? Male wearing pajamas. So yun ang interpretation nun, no? Male wearing pajamas, no? Pajamas intersection male. So male wearing pajamas, that is 0.102, no? So ito yung probability ngayon, no? 0.102. So yun na yung probability. Okay, 0.102. And probability na male siya, no? 'Di ba? Yung A dito, yun yung male. So, ibig sabihin male ito, probability na male. So, yung pinag-add lahat, 0.220, 0.002, 0.160, 0.102, 0.046, 0.084 now equals a 0.614. No? So we will get what? No? So we'll get an answer of 0.166. 0.102 over 0.614, 0.166. Okay? So that's it. No? So ganyan yung application ng conditional probability. No? And then, letter D. No? What is the probability that the traveler is male if the traveler sleeps in pajamas or a t-shirt? So what is the probability that the traveler is male if the traveler sleeps in pajamas or a t-shirt? No? So in this example, no, so we have, so we're looking for the probability that the traveler is male, given that the traveler, which is male, uh, wears pajamas or t-shirt. No? It, wears pajamas or t-shirt. No? So this is the condition here. What is the probability that the traveler is male if the traveler sleeps in pajamas or a t-shirt? So how is the solution to the problem? No? So here's the solution to the problem. So here's the probability that the conditional probability. So probability that the traveler is male given that the traveler wears pajamas or t-shirt. So this is the representation for R. We use union, no? The representation for R, union. Okay, pajamas, union, t-shirt. Okay. So take note, M, P, J, and T, S are events, no? Events yan. Okay? So in that case, so this is probability, no? So we will now apply the conditional probability formula, no? So this is the conditional probability formula over probability of A. Now we have here, so A represents pajamas or t-shirt. So this is A. B represents male, no? The event that the traveler is male. So in here, the event that the traveler wears pajamas or t-shirts or t-shirt, no? The traveler wears pajamas or t-shirt. So that is the event. So we have event B and event A. So in here now, so this is event A, event A, event B. Okay, hope you get it. So in this case, what is the next step? How do we simplify the numerator? So how do we find the probability that the traveler wears pajamas or t-shirt and at the same time the traveler's male? Hmm? So we have now A and B. Okay, A and B. No? So in this case, no? So the solution to here is this. So we just take the probability that the traveler wears pajamas and at the same time, the traveler is male. No? So, ito yung simplification. Pag nakakita ka ng ganito, A union B, A union B, intersection C, no? So, kapag ka ganito yung equation, yung expression, so how do we simplify that? That is simply probability A intersection C, okay? A intersection C, okay? A intersection C union probability, no? Or should I say, ito na yung shortcut eh. Or should I say, union B intersection C. Ayan, no? So, probability A intersection C union B intersection C. Okay? So, ganyan yung simplification. So, kaya mo papansin mo, yung PJ dito ay yung A, yung M dito ay yung C. No? Union TS, yun yung B, M, yun yung C. No? Okay? So, and then, meron tayo ditong over probability that the traveler wears pajamas or t-shirt. No? So, we can now proceed. No? So, how do we simplify this now? We take the union of the two events, no? Events A and B. So, this is now A and this is now B. No? So, probability A union B. By applying additive rules on probability, that is probability of A plus probability of B minus probability A intersection B. My question now is, are A and B mutually exclusive? Are they mutually exclusive? Male wearing pajamas and male wearing t-shirt. So based from the problem, no? So, nakaseparate eh. Ito yung sa pajamas, no? Ito yung sa t-shirt. So, nakaseparate. So, sabihin niyan, they are mutually exclusive. No? Sineparate na. No? So, in that case, so, this will become 0. No? So, this will become 0. And, ang simplification niyan, add mo lang yung dalawang probability. Probability of A plus probability of B. In short, ito siya. Probability A, ito yon pajama, intersection male. So, ibig sabihin yan, male wearing pajamas, no? And then, male wearing t-shirt. So, union yon. So, by formula, applying additive rules on probability. So, we have plus, no? So, ito yon, B. So, we have probability of A plus probability of B. Okay? And then, yung union ng dalawang events, PJ and TS, no? They are also mutually exclusive, no? So, nakaseparate na kasi yung probability. So, ano yung pajamas and t-shirt na tinutukoy dyan? Sabihin yan, regardless whether the traveler is male or female. No? So, i-consider natin yung kabuuan, regardless whether the traveler is male or female. So, sabihin yan, pajamas, male and female should be considered. So, 0.175 yon. No? Yung PJ na yan. Okay? So, yung TS na to, considering also both male and female, no? So, we have t-shirt. Itong dalawa na yan, pag pinag-add mo, 0.134. So, ito yung 0.175 and 0.134. So, yung probability that the traveler wears pajamas and the traveler is male, ano yun dito? Pajama and male. Pajama and male, yung kanyang intersection, 0.102. So, ito ngayon ay 0.102. No? Ayan. Ito naman ay t-shirt na male. T-shirt wearing, should I say, the traveler wears t-shirt such that the traveler is male. No? And also the traveler is male. So, intersection ng dalawang event that the traveler wears t-shirt and the event that the traveler is male. That's me. So, ito siya. 0.046. Okay, 0.046. Kasi intersection no? 0.046. And then, gaya ng sabi ko, ito yung 0.1 pajamas, 175, t-shirt, 0.134. Okay? So, 0.102 plus 0.06, 0.046 over 0.175 plus 0.134. I hope you get it. And we'll get an answer of 0.479. Excuse me. Okay, so that ends letter D. So we now proceed with the next problem. So we have problem number 4. So the problem is, in the senior year of a high school graduating class of 100 students, 42 studied mathematics, 68 studied psychology, 54 studied history, 22 studied both mathematics and history, 25 studied both mathematics and psychology, 7 studied history but neither mathematics nor psychology, 10 studied all 3 subjects, and 8 did not take any of the 3. Randomly select a student from the class and find the probabilities of the following events. Letter A. A person enrolled in psychology takes all 3 subjects. So what is the probability that a person enrolled in psychology takes all 3 subjects? So let us analyze. So we have a senior high school graduating class of 100 students. This represents the population. No? And since this is the population, no? So we have the sample space now, which are high school graduating class. No? High school graduating class in the senior year. No? So the number of outcomes in the sample space is now 100 because there are 100 high school graduating students. No? Okay, so this is now the number of outcomes in the sample space, 100. No? And then 42 studied mathematics. So the number of outcomes in the event M, where event M is the event that the student studied studied mathematics. No, that is the event that the student studied mathematics, and there are 42 outcomes. So the number of outcomes for the event M representing mathematics, no, is 42. Okay, the event that the student studied mathematics is 42. No, the number of outcomes for that is 42. And then also for psychology, we have 68, the number of outcomes for the event PSY representing, so this is the event that the student studied psychology. No? We have 68. And then we have another event. No? The student studied history. No? The number of outcomes for that is 54. So there are 54 students that studied history. No? 22 studied both mathematics and history. Now, we have the intersection of the two events, no? For mathematics and history. So we have the number of outcomes for the intersection of the two events, math and history, no? So intersection of the two events, no? The student studying mathematics and the student studying history. So we have the number of outcomes for that is 22, no? Next we have 25 studied both mathematics and psychology. For mathematics and psychology, we have 25. Take note of the word and. So we use the intersection symbol. No? So we use the intersection symbol for the word and. 25 studied both mathematics and psychology. 7 studied history, but neither mathematics nor psychology. So in other words, what is the interpretation here? 7 studied history, but neither mathematics nor psychology. So, meaning, 7 students studied history only, no? History only ang pinag-aralan nila, no? So, history only. 7. So, the student studied history but neither mathematics nor psychology. History and not mathematics and not psychology. So, there are 7 students. So there are 7 outcomes, no, for the intersection of the 3 events, H, M prime, and psi prime, no. So then we have also 10 studied all 3 subjects. So history, mathematics, and psychology, no. There are 10 students who studied all 3 subjects, history, mathematics, and psychology. And there are also students who did not take any of the 3 subjects, no? Not history, not mathematics, and not psychology, no? So this is now the representation H prime, no? Which is the event that the student did not take history. M prime is the event that the student did not take mathematics. Psi prime is the event that the student did not take psychology. The intersection of the 3 events, no? And is now the is now is now considered, no. So and we consider that, no, considering that we have 8. So we have 8 students who did not take any of the 3 subjects, no. Okay, so sabihin yung H prime intersection M prime intersection psi prime, we considered it as 1. Considering it as 1, so ang interpretation niyan, no, so walang nag-aral sa tatlong subject. Okay? So there is a way on how to simplify, no? Or should I say, ibang solution or ibang way ng pag-represent ng ating solution using Venn diagram. Pwede natin i-apply ang Venn diagram, no? Para hindi tayo mahirapan mag-analyze, no? So ito siya. So ito muna yung mga requirement. Requirement, letter A person enrolled in psychology takes all 3 subjects. No. A person enrolled in psychology takes all 3 subjects. So in this case, probability that the student took history and mathematics and psychology. Kasi sabi niya, a person enrolled in psychology takes all three subjects. So, nag-aral siya ng history, ng math, at ng psychology, given na yung estudyante ay nag-aaral ng psychology. Ano raw yung probability? Yun ang ating concern. We will find the probability that the student takes all three subjects, history, math, and psychology, given that the student takes psychology. No? No? Kasi sabi niya, enrolled in psychology. So, given na nagtitake siya ng psychology, ano yung probability na tinitake niya yung tatlong subject? So, yun ang ating concern. Then, letter B, a person not taking psychology is taking both history and mathematics. So, what is now the probability that the student is taking both history and mathematics, given that the student is not taking psychology? That is our concern. No? Kaya ganito yung representation. H intersection M dahil hinahanap natin is the probability that the person is taking both history and mathematics, given that the person is not taking psychology. No? So, solution using Venn diagram. No? So, using Venn diagram, ito yung sinasabi ko. No? So, ito yung ating Venn diagram. And in this case, so ito yung para sa event M, no? Event M for students taking mathematics. Event H for students taking history. Event PSY for the event for students taking psychology, no? And we analyze. So, kung mapapansin nyo, meron tayong 1, 2, 3, 4, 5, 6, 7, 8. Meron tayong 8 regions, no? 8 regions. Merong white, merong red, may yellow, merong gold, merong orange, may blue, may green. So, sa bawat region na yan, may mga number of students, no? May mga number of students. So, let's now proceed with the solution using Venn diagram. So, sa pagkakastate nito, ang hirap mag-analyze, di ba? Pero pag ginawa mo sa Venn diagram, madali lang. So, gawin na natin. Umpisa natin dito. Meron daw ditong students, no? So, taking all three subjects, 10. Nagtitake ng lahat ng subject, 10. Okay? Ito, nagtitake ng kabuuan, 100. Kabuuan ng mga graduating students, 100. So, yung 100 na yan is the sample space. So, lahat ng students, no, nasakop ng S, na nasa loob ng S na yan, yung sample space, yung rectangle na yan, no? So, yung kabuuan bilang ng mga outcomes ay 100, no? And then, 42. So, 42 na nag-aaral ng mathematics. Okay? Yung iba dyan, hindi lang matang pinag-aaralan. No? Yung iba dyan, hindi lang matang pinag-aaralan. Kaya kung mapapansin mo, ito yung ating math event M for student taking mathematics. So, mapapansin mo yung 4 na region. May red, may yellow, may gold, at saka may black. No? Sabi-sabihin niyan, pag pinag-add ko yung 4 na region na yon, red, yellow, or gold, black, makukuha ko 42. No? 42. Okay? So, ano ba yung palatandaan na ganyan yung drawing? Tignan natin yung ibang given. Kasi sabi niya dito, tatlo yung nag-aaral ng tatlong subject, edi 10. Sorry. Tatlong subject yung pinag-aaralan ng estudyante, no? At yung bilang ng mga estudyante na yan ay 10. So sabihin ito ay 10. Ito ngayon ay 10. Ayan. Kasi sakop ng math, sakop ng history, sakop ng psychology. So yung gitna. So we have 10. No? So ito yung 10, no? Nasa domain ng math, nasa domain ng history, nasa domain ng psychology. No? So yung black region na yan is represents 10 students that are taking all three subjects, history, math, and psychology. And then, we have also, next, yan, alam na natin 10. Ngayon, let's say, yun sa part dito. Ano sa tingin nyo to? Or saan ba ako magsisimula? Yun sa part sa itaas, bakit naging 12 to? So, tingnan natin kung bakit naging 12. Ayan. Kung bakit naging 12 yan, no? Okay. Ngayon, meron ka ditong intersection, no? Ng dalawang events, event M and event H. Okay? Event M and event H. So, ngayon, tingnan natin yung M and H. Ito, 22. Intersection ng dalawang events M and H, 22. So, kung 22 yan, at 10 na ito, yung black region ay 10 na, ibig sabihin, may 12 dito sa yellow region. Pag yung 12 pinag-add ko sa 10, yung 12 and 10 pinag-add ko, I'll get 22. No? Ito yung nagre-represent ngayon sa dalawang region, which is the intersection of the two events M and H. No? Okay? And then, meron tayo dito, 25 naman, math and psychology. Math and psychology, 25. Okay? Math and psychology. So, ito yon. Ito ngayon yung region, no? Yung gold region and black region. No? Yun yung nagre-represent ngayon dun sa intersection ng dalawang events, M and PSY. So, in this case, M and PSY intersection, number of outcomes is 25. So, therefore, kung 10 na ito, 15 na lang ito. 15 plus 10 is 25, right? So, 15 na lang yon. Okay? So, in here, 15 plus 10 is 25. Ito yung bilang ng mga estudyante na nagtitake ng math and psychology. 25. Okay. Next. How about itong naka-orange? Yung orange na to. Orange region. Ilan kaya yung mga students na nandito? Okay, let's take a look at the problem. No? So we have the orange region. So intersection ng history and psychology event. History and psychology. No? Intersection ng history and psychology. So kung mapapansin mo, wala, no? Walang binigay. H and PSY. Pero meron tayong clue. Ito, binigay ito. Number of students taking history but not mathematics and psychology. 7 daw. Ibig sabihin yan, the student is taking history only. No? the student takes history only, 7 of them. So, ibig sabihin, ito yung blue region. 7 lang yung nagtitake ng history. History lang ang pinag-aaralan, I mean. No? History lang ang pinag-aaralan. 7, no? Nag-aaral daw ng history pero hindi nag-aaral ng math at hindi nag-aaral ng psychology. So, meron tayong 7. So, 7 yung ating blue region. Okay? So, yun. Kaya 7 yan. Okay? So, yun ang interpretation. So, 7. Taking history only. Kasi, dito sa part na to, sakop din siya ng psychology, yung orange. Diba? Dito sa yellow, sakop din siya ng math. Diba? Dito sa blue, history lang ang may sakop. Itong blue region na yan, no? So, we can proceed, no? How about, we can now solve for the orange region. Kung ano yung value. Kasi alam na natin kung ilan yung nagtitake ng history. Ang nagtitake ng history ay 54. Kung ang nagtitake ng history ay 54, add lahat natin nung nasa tatlong region ng history. 12 plus 7 plus 10 plus x equals 54. Ayan. Diba? 12 plus 7 plus 10 plus x. So, ito ay nawawala. Ano yung x na yon? Ang total dapat ay 54. So, kung isa-solve natin, 54 minus 12 minus 7 minus 10. So, ang makukuha natin ay 54 minus 12, 42. 42 minus 7, 35. 35 minus 10, 25. Is it correct? 25? Yes, 25. No? So, 25 nga siya. So, yun ang value ng x, 25. So, we can now proceed, no? Okay, so, okay na to. Pupunta naman tayo dito sa math. Kasi binigay yung, meron na tayong tatlong region 12, 10, 15 na merong value. So, itong red region, malalaman natin kasi meron tayong clue. Binigay yung number of students taking mathematics na 42. No? So, kung binigay yung 42, kung 42 yan, okay. So, we have, sabihin natin x plus 12 plus 10 plus 15. No? X plus 12 plus 10 plus 15 equals 42 for the mathematics. No? And x plus 22 plus 15, 37. Right? 37 equals 42. And x is 42 minus 37. So, we get 5. No? So, is it 5? Ito muna yung nauna. Pero 5 yan. Ayun, 5. Okay. So, 5. Okay? So, 5. Okay, how about this? 18. Paano nakuha yung 18? Check natin. No? 18. Paano nakuha yung 18? Check natin. So, given na yung tatlo 15, 10, 25. 15, 10, 25 plus x. No? Yung is para sa 18. Equals, ilan lahat na nagtitake ng psychology? Binigay ba sa problem? Yes, 68. No? 68. Okay? 68. So, we have 25 plus 25, 50 plus 8 plus x, 68 equals 68. So, x is 68 minus 50. We got 18. Kaya siya 18. Okay? So, that completes. Meron pa. The number of students did not take all three subjects. 8 daw yon. So, sabihin, yung 8 outside ng tatlong events, M, H, and P as well. So, pero nasa sample space. So, ibig sabihin yung nasa puting region. Yung nasa puting region, yun yung para sa mga 8 students na hindi nag-take ng Math, History, and Psychology. Okay? So, check nga natin kung 100 ba yung total. Kasi sabi dito, 100 daw ang total eh. Check natin, 8 plus 5, ito, plus 12, plus 7, plus 10, plus 15, plus 25, plus 18, plus 8. Okay. Okay, tignan natin. 13, 12 plus 7, 19. Okay. 10 plus 15, 25. No. 25 plus 18, 43. Okay, 43. Plus 8. Okay. 13 plus 19, 32. 25 and 43, 68. Then plus 8. 32 and 68. Oh, wait. Nagkamali ba ako? 8, 5, 12, 7, 10, 15, 25, 18, and 8. Ah, okay, okay. Naulit ko yung 8. Naulit ko yung 8. Okay. Naulit ko yung 8, 13, 19, okay, 25, 25, 18, 43, okay, and then 12, 32, 25, 43, ano yung 35, 43? 68. 25, 43 is 68. Ayun. Okay, 8, 68, 32, 68, 100. There. So, yun, kompleto na. 100. Okay? So, I hope you get it, no? So, we proceed. So, this is now our Venn diagram. We can now solve the problem for letter A. So, what is the probability that the student takes all 3 subjects given that the student is enrolled in psychology? So, ito yung solution. Probability that the student takes all 3 subjects given that the student takes psychology. So, apply natin yung conditional probability formula. So, we have this solution. So, we have probability A intersection B. So, psychology, intersection, yung tatlong events. Okay, ito yun. Ito yung sa A, ito yung sa B. Ito yung sa A. Okay? Kasi A ito eh. No, ito ay B. Okay, so alam nyo na yan. And then, itong lilitaw. So, paano naging 10 over 100? Ano sa tingin nyo, paano naging 10 over 100? Okay? So, 10 over 100, paano siya naging 10 over 100? So, ano ba yung simplification nito? Probability, nagtitake ng psychology and nagtitake ng history, math, and psychology. Ano yung simplification niyan? Umulit lang yun, di ba? Yun din ito. Ito rin to. Probability, yung simplification niyan ay mawawala yan. ito rin yun. And mathematics, history and mathematics and psychology. Kasi, nagtitake ng psychology and nagtitake ng history and math and psychology. So, pareho lang yon. So, simplify natin. Ito na rin yon. History and math and psychology. Okay? So, ano yon? Ilan sila? 10. Ito. Nagtitake ng history and math and psychology. No? From our Venn diagram, 10. Bakit ba siya over 100? Kasi probability. Ano yung ating classical probability formula? No? Ang classical probability formula, probability ng event A, no, ay equal sa number of outcomes for the event A over the total number of outcomes in the sample space. So, ang total number of outcomes sa sample space natin ay 100, di ba? Kasi may 100 graduating students. 10 yung sa event. 10 yung outcomes sa event na nagtitake ng 3 subject, history, math, and psychology. Okay? So, ito yon yung 10. Kaya 10 over 100. How about you to? Paano naging 68 over 100? Classical probability formula pa rin, no? So, in that case, ilan yung nagtitake ng psychology? 68. Kasi probability na nagtitake yung student ng psychology. Ilan yung nagtitake ng psychology? So, tignan mo yung event PSY sa loob niya. Bilangin mo lahat or add mo lahat nung nasa 4 regions. 15 plus 10 plus 25 plus 18. You will get 68. Or tingin na lang dito. Number of students taking psychology is 68. Bakit over 100? Kasi yun ang number of outcomes sa ating sample space. Okay, 100. And then we get 5 over 34. Ito yung simplest form. No? So you can also express that in decimal if you like. Okay, letter B. Probability that the student takes history and mathematics given that the student does not take psychology. Okay. So, ito yung ating B. Ito yung ating A. Ito yung ating A. Ito yung ating B. Ito yung ating A. Okay? So, alam nyo na yan, yung conditional probability formula. And then, so how do we solve the problem now? Probability that the student is not taking psychology but taking history and mathematics. So, sabihin, hindi nagsa-psychology. So, sabihin, outside ng domain ng psychology. No, na-imagine nyo, hindi nagsa-psychology, lahat ng nasa labas, kumbaga, ng psychology, yun yung psi prime, di ba? At ito, and, or but, okay? And, nagtitake ng history and mathematics. O, tignan muna natin yung nagtitake ng history and mathematics. Nagtitake ng history and mathematics. Tignan natin yung nagtitake ng history and mathematics. History and mathematics, ito. Ito yung 12 and 10, right? Nagtitake ng history at saka mathematics. So, yung bilang ng outcomes, no, dun sa intersection ng dalawang events, H and M, is 22. 12 plus 10 is 22. Kaya lang, meron pa siya dito, and not taking psychology. So, ibig sabihin, sa labas ng psychology sa labas ng domain nitong psychology event, no? So, sabihin niyan, 12 lang. Kasi sakop, yung sa psychology, sakop niya tong 10 eh. No? Sakop niya tong 10. Okay? So sabihin niyan, 12 lang. So, 12 yung number of outcomes dito. Okay? Not taking psychology and taking history and taking mathematics. No? So, history and mathematics. No? But the student does not take psychology. So, outside sa psychology, pero nagtitake ng math and history, edi yung 12 ang tinutukoy. No? Okay? So, yun yon. So, 12. 12 over 100 kasi yun ang bilang ng graduating students. Okay? We apply the classical probability rule. Probability na ang estudyante hindi nagtitake ng psychology, bilang ng mga estudyante na hindi nagtitake ng psychology. Ilan sila? Add mo lahat yon. Add mo lahat. Sa labas ng psychology, 8 plus 5 plus 12 plus 7. Yun na, yun yun. 8 plus 5, 13. 13 plus 12, 25. 25 plus 7, 32. No? So, 32 over 100. 32 over 100. Okay? So, ano yung simplification niyan? 3 over 8, no? 3 over 8. Okay, so we can now proceed, no? So, we now proceed to problem solving on conditional probability applied for dependent events and independent events. So, number 1, refer to the information on 40 students given in table 6.2.3. Are events female and in favor independent? So let us analyze the table. So, ang concern natin is, are events female and in favor independent? Okay. So, ito yung ating table, two-way classification of student according to sex and according to whether they are in favor or not. So, in this case, we are to determine whether the events F and I independent. So how do we know if they are independent or not? So we recall, no? So what shall we recall? Probability B given A, if that is equals to the probability of B, no? Without the occurrence of A, if they are equal, no? Therefore, B is an independent event. Okay? So likewise, if probability of A given B equals to probability of A, okay, sabihin niyan, the probability that event A will happen given that event B had event B occurred, no? If that is equals to probability of A without the occurrence of B, no? Pag naging equal sila, no? A is said to be an independent event, no? Independent event, no? Ayan. Pagka naging true yan. Okay? So, dapat masatisfy yung dalawa na to. Okay? Ito, tsaka ito. Para masabi natin na A and B are independent events. So, in this case, F and I are independent events. Tignan natin kung masasatisfy. No? Okay, we can proceed. No? So in this case, F and I, are events F and I independent? So ito yung form, ano natin, conditional probability formula. Okay? So probability I intersection F over probability of I. No? And then, ano yung simplification nito? Ano yung I intersection F? Ilan yung bilang ng mga tao o mga estudyante in favor at the same time female? 17, no? In favor na female pa, 17. 17 over, no? 17 over yung total, no? Ano yung total? 40. Yung number of outcomes in the sample space. 40, diba? 40. 17 over 40. Yun ang probability para dito. Probability para sa I in favor, regardless of the sex, we consider yung 23. No? 6 plus 7 is 23. 6 plus 17 is 23, I mean. No? So, we have 23 over 40. Okay? So, ganun lang siya kasimple. No? So, ano yung ano niyan? So, ang sagot ay 0.739. 0.739. Okay? Ngayon, ikumpara na nga natin na if, take note if probability of F given I, if probability of F given I is equals to probability of F, no? So, therefore, F is an independent event, no? F is independent, no? Okay? So, in this case, ano yung probability ng F sa ating figure, no? Sa ating table? Female. Ano yung probability na female yung student? So, ilan ba lahat ng female students? Ilan ba lahat ng female students? 17 plus 8. Well, regardless kung in favor or hindi. 25. 25. Okay. Ilan lahat ng outcome sa sample space? 40. So, 25 over 40. Ano yung 25 over 40? 0.625, no? 0.625. Okay? 25 over 40. 0.625. Okay. So, ano yung interpretation nito? So, F is not independent, no? Event F is not independent. No? Yun ang interpretation. O, tingnan naman natin yung isa. I, probability that the student is in favor given that the student is female. So that is equals to the probability, no, that the student is a female and at the same time in favor over probability that the student is female. So in this case, how many students are in favor and at the same time female? 17, diba? 17 out of, pareho din dito, diba? 17 out of 40, no? Over probability na female. Ang probability na female, no, 25. Iko-consider mo pati in favor and against. No? 25. Okay? So, 25. 25 over 40. No? So, ito siya. 17 over 40 over 25 over 40. Female, 25/40. So, 0.680. O, ano naman yung probability na in favor? O, note, no? If probability I given F is equals to probability of I, therefore I is independent. No? I is independent. No? O, tignan natin. Ano yung ating bilang ng outcomes sa event I over number of outcomes in the sample space by classical probability formula. So, ilan yung number of outcomes for I. So, we have for the in favor 23, right? Regardless whether male or female, number of outcomes for event I is 23. Kasi yun ang total eh. Okay? So, 23 out of 40. 23 out of 40. Ano kaya yung 23 out of 40? 0.575. No? 23 out of 40, 0.575. So, therefore, hindi rin equal kasi ito na hindi naging equal dyan. Ito hindi rin naging equal dyan. So, anong conclusion natin? Dahil hindi equal, no? Since probability of F given I is not equal to probability of F and probability of I given F is not equal to probability of I, therefore no. No? So, no ang ating sagot. Are events female and in favor independent? No. No? So, ibig sabihin yan, kabaligtaran ng independent. No? Which is dependent. No? So, ganun lang kasimple. Okay? So, we can now proceed. So, let's now answer line number 2. A box contains a total of 50 bulbs that were manufactured on 2 machines. Of them, 30 were manufactured on machine 1. Of the total bulbs, 10 are defective. Of the 30 bulbs that were manufactured on machine 1, 6 are defective. Let D be the event that a randomly selected bulb is defective, and A be the event that a randomly selected bulb was manufactured on machine 1. Are events D and A independent? So let us answer. So we have this solution to our problem. So we analyze the problem. So pwede tayong gumawa ng table para hindi tayo mahirapan mag-analyze. So a box contains a total of 50 bulbs. Ang total is 50 that were manufactured on 2 machines. So meron kang machine 1 and machine 2. Of them, 30 were manufactured on machine 1. So total ng mga nagawa sa machine 1 ng mga bulbs ay 30. Of the 10 bulbs that are defective, of the total bulbs, 10 are defective. Of the total bulbs, 10 are defective. So ito yung total, no? Para sa bulbs na defective, ang total ay 10. Ayan, 10. Okay? Para sa bulbs na defective, ang total ay 10. No? Para sa lahat ng bulbs na nagawa sa machine 1 ay 30. No? Yung box, naglalaman daw ng 50 bulbs, yun ang total. No? So, kombinasyon na yan. Yung iba dyan, gawa sa machine 1, yung iba sa machine 2. Yung iba dyan, defective, yung iba hindi. Ano? So, of the 30 bulbs that were manufactured on machine 1, 6 are defective. So, ito yon. Sa 30 bulbs daw na nagawa sa machine 1, 6 yung defektibo. Okay? Let D be the event that a randomly selected bulb is effective, and A be the event that a randomly selected bulb was manufactured at machine 1. Are events DNA independent? So how do we solve the problem? So we are to determine whether D and A are independent now. So if probability of D given A equals the probability of D, therefore D is independent. Okay. Also, if probability of A given D is equals to probability of A, therefore A is also independent. Okay, it is also independent. Alright, so let us now analyze. Okay, so alam natin yung D ay yung event na yung sinelect na bulb ay defective, no? At yung A ay yung event na yung sinelect na bulb ay ginawa sa machine 1, no? So in this case, alam natin yung bilang ng mga bulbs na defective ay 10 total. Bilang ng mga bulbs na ginawa sa machine 1 ay 30, no? 30. Now, ngayon, yung sa 30 na yan, yung iba dyan, yung iba dyan ay defective, no? Yung sa 30 na yan. Okay? Tapos, yung number of defective na 10, yung iba dyan, gawa sa machine 1 at yung iba sa machine 2. No? Okay? So, in this case, ang bilang ng lahat ng outcome sa ating sample space ay 50. Kasi meron tayong box containing 50 bulbs. No? At meron ka dito, yung 6 na to, yun yung intersection ng DNA. Kasi para sa event, yung event A ay yung event na yung bulb ay ginawa sa machine 1. Yung D naman ay yung event na yung bulb ay defective. No? So, yung DNA na to, are they independent? Are they independent? Okay? Sabihin yan, let's say, nangyari na defective, maapektuhan ba yung chance na gawa siya sa machine 1? Or the opposite? Given na gawa siya sa machine 1, maapektuhan ba yung probability na defective yung bulb? So, tignan natin. So, yun ang concern natin. No? So, in this case, so intersection ng dalawang events, D and A, we have 6. No? So, meron tayong 6 na outcomes. No? So, charge ko lang. Wait lang, class. Alright, so we continue. And then, we proceed. Okay, ito yung solution. Kukunin natin yung probability of D given A So, kasi ang concern natin ay malaman kung independent ba yung dalawa na yan, D and A. So therefore, gagamit tayo ng conditional probability formula. At ikukumpara natin ito sa probability of D. No? Okay? So, we proceed. Probability of D given A, that is probability A intersection D over probability of A, applying conditional probability formula. Okay, A intersection D. So, madali na lang yan. So, ito rin yung 6D niyan, no? And probability A intersection D, that is number of outcomes dun sa dalawa. Dun sa intersection ng A and D over total number of outcomes in the sample space. No? Okay? So, ito siya. Tapos yung probability ng A, gawa sa machine 1 yung bulb, bilang ng mga bulbs sa machine 1, okay, nagawa sa machine 1, no? Bilang ng mga bulbs nagawa sa machine 1 over total number of outcomes or total number of bulbs in the box, no? Okay? So, ito siya. 6 over 50. Kasi, ito yung 6. Diba? Ito yun, 6. Over 50. Bakit over 50? Kasi ito yun, number of outcomes in sample space. Then, 30. Bakit 30? Number of outcomes sa event A. Ito yun, 30. Number of outcomes sa event A. 30. And then, 50. Ito sa sample space, number of outcomes. And we get 0.2. Okay? How about probability of D? Number of outcomes for event D over number of outcomes in the sample space. So our answer is number of outcomes for event D is 10. 10 over 50. Diba? So meron tayong 10 over 50.2. So kung mapapansin nyo, equal. No? So, sabihin yan, D is an independent event, no? Okay, the event D is an independent event, no? D is independent. Ayan, no? So, we can now proceed. Tignan naman natin whether yung event A ay independent din, no? Yung event A. So, by formula, probability of A given D, no, equals to probability of D and A, or probability of D intersection A over probability of D. So, probability of D intersection A, so bakit siya 6 over 50? Pareho din siya sa probability A intersection D, pareho lang yan. Kahit magkabaligtad pa yung dalawa, no? A and D and D and A. Basta intersection, pareho pa rin, 6 over 50. Probability of D, probability that the bulb is defective, no? So, probability that the randomly selected bulb is defective, no? We have 10 over 50, no? 10 over 50. No? Probability na defective, kung ilan yung bulb na defective over yung total, 50. So, we get 0.6. Ikumpara natin sa probability na yung bulb ay ginawa sa machine 1. So, what's the probability that the randomly selected bulb was manufactured on machine 1? So, we get the number of outcomes for event A, no? How many bulbs were manufactured, no, in machine 1, on machine 1, no? How many bulbs? 30. Divide natin sa 50. So what shall we get? So we will get zero point 0.6. So 0.6, and they are the same. Event A also is independent. A is also independent. No? A is also independent. Okay, that's it. No? So I hope you get it. No? So we can now finalize our answer. Since a probability of D given A equals the probability of D, and probability of A given D is equals to probability of A, no? Therefore, yes, events D and A are independent. So that is our answer.